Okay, so today I want to talk about section 7.3, the trigonometric substitution. This is like a two-day lecture. Here, this is outline. Why do you need trigonometric substitution? Second one, what is the trigonometric substitution? Last one, I want to give examples by using trigonometric substitution. This is like a two-day lecture. The first one, the evaluate integral x square root of 4 minus x squared dx. Do you know how can you calculate this integral? What kind of technique do you want to use for solving this problem? So far we learned the three techniques, the formula, the example is integral sine x is, the negative cosine x d, the plus c. Another method is u substitution. The last one is integration by parts. So what kind of technique do you want to use for solving this problem? Do you have any idea? How can you solve this problem? The u sub? Yeah, in this case, you have to use u substitution. What is u? So what is u? The u is, you can guess, what is u? The 4 minus x squared. It's good. Yeah, 4 minus x squared. To find du. The du is 4 minus x squared prime dx. The 4 prime equal to 0. Negative x squared prime is negative 2x dx. You can divide the both sides by negative 2. So we have, you can divide the both sides by negative 2. So we have minus 1 over 2 du equals the x dx. So we have it like this. The next thing, you have to substitute. This is integral. The 4 minus x squared is u, the square root of u times the x dx. X dx is minus 1 over 2 du, the negative 1 over 2 du. You can take out minus 1 over 2. Integral, you can change square root of u to u to the power 1/2 du. The next, keep coefficient minus 1/2. You can find integral u to the 1/2 by using power rule. 1 over 2 plus 1 u to the 1 over 2 plus 1 plus c. To simplify, the minus 1 over 2 times, what's that? So this part is same to 1 over 2 plus 1 is 3 over 2. You flip 2/3. So we have the 2/3 u to the 3 over 2 plus c. Cross out 2. The answer is minus 1/3 u to the 3 over 2. You can change back. This u is here. 4 minus x squared minus 1/3. 4 minus x squared to the power 3 over 2 plus c. This is not absolute sign, parentheses. Okay, this is all procedure for solving this problem, right? Like this. The next one. I'm going to give the one more example. The one more example is you have to eliminate x. Only the square root of 4 minus x squared. The u substitution is possible or not? What do you think? Could you use u substitution for this problem? Integral square root of 4 minus x squared. So what do you think? Yeah, we cannot use it. You cannot use this one. It is difficult to evaluate this integral by using substitution rule. So how can you solve this problem? We learn new technique for solving this kind of problem that we call trigonometric substitution. So I'm going to explain what is the trigonometric substitution. So the trigonometric substitution is from U substitution. We can use like this one. 이내걸 f of g of theta times g prime of theta d theta, like a problem is given. You can use U substitution. I don't want to use U. The x equals inner function g of theta. The x is inner function g of theta. So dx is g prime of theta d theta. You substitute. This is integral f of the g of theta is x. G prime of theta d theta is here, dx. This is called substitution rules. We think about backward, like this. integral f of x dx is given. So here, integral f of x dx is given. You can use x equals here, g of theta. X equals g of theta. Find differential form dx. dx is g prime of theta d theta. So you can change integral f of the x is g of theta times dx is here, g prime of theta d theta. So like this. You think about this is going backward, like this. Here, this kind of substitution is called inverse substitution because this is substitution rule going backward. We call inverse substitution or trigonometric substitution. Why do we call it trigonometric substitution? Because the g of theta is trigonometric function. This is the reason. You can choose g of theta is trigonometric function. You can usually choose sine function, tangent function, secant function. You can choose a cosine function. The result is exactly same for sine function. You choose a cotangent, the exactly same to tangent. You can choose a cosecant, exactly same to secant. So what does it mean? Only choose three possibilities: sine function, tangent function, secant function. So we call trigonometric substitution. So we are going back to this problem again. The 4 minus x squared dx. So what is x? You can choose. Do you remember previous one? X is what? G of theta. So this is like sine function, sine function, tangent function, or secant function. How can you choose? So this one. Use Pythagorean identities for trigonometry. So do you know this one? What is 1 minus sine squared of theta? Do you remember? 1 minus sine squared of theta? So could you write your answer on chatting board if you know this answer? Yeah, cosine square. Yes, this is cosine square. Do you know 1 plus tangent square? The 1 plus tangent square is, yes, secant square. The secant square minus 1 is only subtract 1 from both sides. 1 is crossed out. The secant square of theta minus 1 is tangent theta. So we have like this one. We have three kind of things. So compare these identities with 4 minus x squared. So let me see. We have negative sign. So which one? Here. Negative sign and negative sign. So one more. The constant is front. Which one has a constant? Yeah, this is has a constant. Exactly 1 minus sine square. But this number is 4. How can you do that? You can multiply the both sides by 4. This is the idea. You can change like this. So what's that? Distribute 4. The 4 minus 4 sine squared is 4 cosine squared. So you can change it 4 sine squared theta to the 2 sine squared of theta. You can compare. What is x here? This is 4 here. What is x? X is the same to 2 sine theta. This is idea. X is what? 2 sine theta. What's it like dx? The 2 sine theta prime is 2 cosine theta d theta. So next, so you have to substitute these things into here and solve. This is the whole idea. So let me see. So before you solve this problem, so you need to know this result. So do you remember half angle formula? Do you remember half angle formula of a cosine square of theta? So if you learned this stuff the last week, with Kasha, the section 7.2, the cosine square of theta is 1 over 2 times 1 plus cosine 2 theta. So do you know double angle formula? The double angle formula, sine 2 theta equals, do you remember? If you know double angle formula of sine 2 theta, could you write your answer on the chatting board, please? Yeah, 2 sine cosine, it's good, thank you. The 2 sine theta, cosine theta. The one more, cosine k theta d theta is 1 over k sine k theta plus c. The next, we are going to our problem. So far we use x equals to 2 sine theta, dx equals 2 cosine theta d theta. You can solve integral the square root of 4 minus x squared dx. So you can substitute. This is integral square root of this x is 2 sine theta, you plug 4 minus 2 sine theta squared times the dx is here, the 2 cosine theta d theta. 2 cosine theta d theta. So next, I'm going to simplify this one. How can I simplify? Here, square root of 4 minus 2 sine theta square is 4 sine square of theta. This is same to square root of factor 4, 1 plus sine square. The next, you can use identity. What is a 1 plus sine square theta? What's 1 plus sine square theta? Do you remember? Oh, sorry. This is a negative. This is typo. So this is a negative sign. Not plus. Minus. What's 1 minus sine square theta? Yep. This is right? Cosine square theta. Just eliminate square root. This is 2 cosine theta. So we have, this is same to integral. So 2 cosine theta is square root part. Remaining one is 2 cosine theta d theta. This is like 2 times 2 is 4. Take out 4. Integral cosine square of theta d theta. This is like I. It's good. The next thing. So we are going back to section 7.2, the trigonometric integral. How can you solve integral of cosine square of theta? 2 is like even power. Remember? How can you solve 4 times integral cosine square of theta d theta? What's like the next step? Do you know next step? Here. This is same to, you can use half angle formula. Yeah, cosine square of theta. You can change it to the half angle formula. This one. 1 over 2, 1 plus cosine 2 theta. the 4 times integral 1 over 2, the 1 plus cosine 2 theta. d theta. The 2 is crossed out, only 2. So we have 2 times integral, the 1 plus cosine 2 theta. Cosine 2 theta, d theta. So like this. The next tip. You can keep 2. Integral 1 is just theta. Plus the integral cosine 2 theta is, you can use this formula. Integral cosine 2 theta is 1 over 2 sine 2 theta plus c. So like this. Theta plus 1 over 2 sine 2 theta plus c. The next one, you have to change back theta value to x values, right? Change back to x value. So we have trouble. Sine 2 theta. We have only sine theta. So this is like 2 theta. You have to eliminate 2. How can you eliminate 2? We can use double angle formula. 2 sine theta, cosine theta. So this is same to 2 times theta plus 1 over 2 times sine 2 theta is 2 times sine theta cosine theta plus c. So what happens? 2 is crossed out. This is 2 times theta plus sine theta cosine theta plus c. The next tip, you have to change it back to x value by using this relation, x equals to 2 sine theta. So here, x equals 2 sine theta is given. The next divided by 2, the both sides. So we have x over 2 equals sine theta. The next tip. How can you change it to the only theta like this? Not difficult. You can use inverse sine function. So this is exactly same to inverse sine of x of 2 equals theta. So we have it. So first one, we reserved first one. 2 times theta is inverse sine of x over 2 plus, was it like a sine theta? Sine theta is here, x over 2, is right? The sine theta is x over 2, so we have it, x over 2 times, how can you find the cosine theta? We use this relation. X over 2 equals sine theta. How can you find the cosine theta? We have 2 ideas. So cosine square of theta is 1 minus sine square, take square root. Cosine theta equals square root of 1 minus sine square, plug x over 2, you can find. This is one way. The another method is I want to use triangle. Right triangle, angle theta. You can use definition. Do you know definition of sine theta in right triangle? What is the definition of sine theta in right triangle? Do you remember? Which one? Hypotenuse and the opposite, the adjacent. Yeah, this is exactly what? The opposite over hypotenuse. So we have opposite is here. Hypotenuse. How can you find adjacent y? You can use Pythagorean theorem. The x squared plus y squared equals 2 squared. You subtract x squared from both sides. The y squared equals 4 minus x squared. You can take square root, y is square root of 4 minus x squared. So what's like cosine theta? Cosine theta is like adjacent over hypotenuse. So we have the square root of 4 minus x squared over 2 plus c. The next you have to distribute 2. Distribute 2, this is coefficient. 2 times inverse sine of x of 2. The 2 is crossed out, only x square root of 4 minus x squared over 2 plus c. So that's it. This is the whole idea for solving this kind of problem. So we call the trigonometric substitution. The trigonometric substitution. This is the idea. So far so good. Do you have any questions so far? So if you have any question, always write your question on the chatting board. I'll answer your question. So this is the idea here, like this. So how can you use trigonometric substitution? The important thing is here, integrand has 4 minus x squared. In this case, you can use x equals to what? The 2 sine theta. You can use identity. The 1 minus the sine square equals cosine square of theta. You can use triangle, the change back to x value. This is the whole idea. So I can summarize and general form here. So we have expression. This one is expression. We have 3 kind of expressions in integrand. The first one is like a square minus u square form. The second expression is here. The second expression is the a square plus u square. The third expression is the u square minus a square. We have 3 expressions. This is what is a? The a is constant. The constant. Was it like u? The u is function. The previous one is 4 minus x squared. X is u. This is like a function. U is a function. So how can you do like a substitution? This is like a substitution is like this. The first case, a square minus u square. In this case, u equals a times sine theta. Find du. The du is a times sine prime is cosine theta d theta. Like this. Second expression, a square plus u square. Was it like u? The u is the a times tan theta. The du is a times tangent theta prime is secant squared. Secant square of theta d theta. The next one, last one, u square minus a square. So this case is u equals a times secant theta. Was it like du? The du is the a times secant prime is secant theta here, secant theta times tan theta d theta. So we have this one. The next two. Do you remember? We have the 4 minus x squared. How can you change it to the simple one? The 4 minus 4 sine squared theta, factor of 4. The 1 minus the sine squared of theta is cosine squared of theta. What does it mean? You can use identity. You can use identity. The first one, we use this one. 1 minus sine square of theta is cosine square of theta. Use this identity. Second one, You can use u equals a tangent theta. So we use 1 plus tangent square of theta equals secant square of theta. The last one, u equals a secant theta. We use this identity. Secant the square of theta minus 1 equals tangent square of theta. You can change it to the simple form. The next two, how can change theta to x variable? How can change theta to x variable? We use triangle here. Triangle. This is idea. So here, you can divide the both sides by a. So what's that? So we have the u over a equals sine theta. You can draw triangle. So draw triangle like this. So sine theta is u over a. How can you find adjacent? You can use Pythagorean theorem here. So we have u square plus y square equals a square. You subtract u square from both sides. The y square is the a square minus u square. You can take square root. Y is square root of a square minus u square. You can use triangle. So similar. Second case, same. Divide by a from both sides. So like this, we have u over a equals tan theta. You can use triangle, the same. Do you know what is tangent theta in right triangle? Could you write your answer on the chatting board, please? So it's right, opposite over adjacent. You're right. This is opposite over adjacent. So we have this one. How can you find hypotenuse is y? Same. You can use Pythagorean theorem. So we have the a square plus u square equals y square. Take square root. Y is the square root of a square plus u square. So that's it. This is the whole idea. The next one, last one, divide by a. Divide by a. So what's that? The u over a is secant theta. Secant theta, same. You can draw triangle. So like this, angle theta. Do you remember what's the definition of secant theta? So what's that? The secant theta is exactly 1 over cosine theta, right? 1 over cosine theta. So what is the answer? What is secant theta? So do you know cosine theta? Cosine theta is, yes. So cosine theta is exactly adjacent over hypotenuse. The secant theta is reciprocal. Hypotenuse over adjacent. It's good. So we have some here, hypotenuse. Oh yeah, hypotenuse over adjacent. Exactly what? Here, u over a. You can find this y. How can you find? Same. You can use here, same. The Pythagorean theorem. So we have a square plus y square equals u square. You subtract a square, y square equals u square minus a square. Take a square root. We have the square root of u square minus a square. This is like a whole idea for solving this problem. Anyway, what's like main idea? We have three things. We have expression a square minus u square, a square plus u square minus a square. You have to use substitution, a sine theta, a tangent theta, a secant theta. You have to use identity. 1 minus sine square is cosine square. 1 plus tangent square equals secant square. Secant square minus 1 is tan square. You can change it back to x value by using triangle. So this is a whole idea for solving this kind of problem. So I'm going to give the more examples here. This is like a summary, so like this. Here. So let me see. We have expression x squared minus u, 9 is here, is right? X squared minus 9. So here, x squared minus 9 is given. You can compare. So this is the same to x squared minus 3 squared. The previous one, we have u squared minus a squared form. Do you remember, was it like a u? In this case, u is a times secant theta. So like this one, was u? This u is log of x. This is x. So a is 3. So we have x equals 3 secant theta. 3 secant theta. Was it like dx? Dx is 3 secant theta prime 3 times secant theta, tan theta, d theta. This is the whole idea. This is the whole idea. It's good. So you have to substitute. This is same to integral. So x is here, 3 secant theta. So we use 3 secant theta squared over the square root of this x is also 3 secant theta. 3 secant theta square minus 9 times the dx is here. 3 secant theta tangent theta d theta. The 3 secant theta tangent theta d theta. So like this. The next two, you need to simplify. integral top one is 9 secant square of theta over. Was it like a bottom one? I can do right here. The bottom one is, we can use this rule. The square root of the 3 secant theta square is 9 secant square of theta minus 9. You factor out 9, square root of 9 times the secant square of theta minus 1. So to remember, what is secant square of theta minus 1? What is secant square of theta minus 1? 10, is it right? 10. Yep. I know this is you know the everything is good. The tangent square is good. Tangent square of theta. So you can eliminate square root. The square root of 9 is 3. The square root of tangent square of theta is only 10 theta. So we have it. You plug. Bottom one is 3 times 10 theta times 3 times secant theta times 10 theta d theta. So what happens? 3 is crossed out. Tangent theta is crossed out. So we have integral. So you can take out 9. The 9 times secant square of theta times secant theta here. Secant square of theta times secant theta is secant cube theta d theta. It's good. So, do you learn integral secant cube theta d theta? Do you know what is integral secant cube theta d theta? How can you solve? Do you know this problem? Integral secant cube theta. Do you know? So if you don't know, I just explained it right now. If you know these kind of things, I can skip or something like that. So what do you think? Do you know how can you solve integral secant cube theta d theta? Could you run your answer? If you know, yes. If you don't know, no. I'll explain right now. Yep. So what do you think? Integral secant cube theta? So I think I need to explain here. So here, integral secant cube theta d theta. How can you solve? You can change integral secant theta times secant square root of theta d theta. So let me see. The integral secant cube theta, so you cannot solve this problem by using formula, impossible. You can use U substitution, also impossible. We have only one remaining method, integration by parts. How can you do integration by parts? So you can choose U and dv very carefully. So U is here, only secant theta. Here, the dv is secant square root of theta d theta. You can choose it like this. Was it like a du? Du is secant prime. The secant theta tan theta d theta. Find v. What's v? Do you know v? The dv equals secant square root of theta d theta. What's v? Do you know v? Yes. Integral secant square root of theta is tan theta. Integral secant square root of theta is tan theta. So next to here, u times v. So we have secant theta times tan theta minus integral. So v times du. V times du. The tangent times secant times tangent. You can rearrange secant times tangent, secant times tangent squared. We have secant theta times tan squared. So like this, d theta. How can you solve secant theta times tan square root of theta? So you can use identity here, secant theta tan theta minus integral secant theta times tangent square root of theta is exactly secant square root of theta minus 1 d theta. So next, this is secant theta times tan theta minus integral. You can distribute secant theta exactly secant cube theta minus secant theta t theta. So like this. The next, this is same to secant theta times tan theta. You can distribute negative integral to the first and second one. So we have negative integral secant cube theta, secant cube theta. The negative integral times negative is positive. The positive integral secant theta d theta. So like this. So my question, what is integral secant theta d theta? Do you remember integral secant theta d theta? Do you know? Do you know formula? Integral secant theta d theta? Yeah, to add up absolute value of secant plus 10. So you can change it. This is same to secant theta times tan theta minus integral secant cube theta d theta plus add up absolute value of secant theta plus tan theta. You can find this kind of thing is in the section 7.2, the Kasha's lecture, you can review again. So we have it. So what happens? So this is exactly same to original one, right? This original one is same to this one. You can rewrite. This is original one. Integral secant cube theta d theta is this one. So what happens? So we have integral secant cube is on the right hand side. Integral secant cube is exactly on the right hand, left hand, right hand side, the both sides. So how can you do that? You add integral secant cube theta d theta. You can add integral secant cube d theta. What happens? Cancelled. You can add these two integrals we have. So this result we have here 2 times integral secant the cube theta d theta equals remaining part is secant theta times tan theta plus ln of secant theta plus tan theta plus tan theta. The next divide by 2. Divide by 2. What happens? 2 is crossed out. So 2 is crossed out. So this is crossed out here. Next, this is indefinite integral. You need to write C. This is the whole idea. So you have to put this value into here. This is same to what? 9 times. So this one is 1 over 2. So we have secant theta tan theta plus the ln of absolute value of secant theta plus tan theta whole thing plus C. So we have it. This is the whole idea for solving this problem. So yeah, this is a very complicated one, but this is a really good exercise problem. Really good exercise problem. Here, this is the previous one. So like this, so we have it. The 9 over 2 secant theta tan theta plus ln of secant theta plus tan theta plus C. What's the next step? So you have to change it to the x value. How can you change it? You can use triangle here. X equal to 3 secant theta is given. You can divide by 3 from both sides. 3, 3. So we have x over 3 equals secant theta. You can draw triangle, angle theta, right? What's like a secant theta here? Hypotenuse over adjacent, you can find opposite by using Pythagorean theorem. So we have here x squared equals 3 squared plus y squared. Subtract 3 squared from both sides is gone. So y squared equals x squared minus 9. Take a square root, the square root of x squared minus 9. So we have it. So what's that? So this is same to 9 over 2 times, what's it like a secant theta? The secant theta is here, x over 3. So we have x over 3. X over 3 times. The tangent theta is, you can use triangle, the opposite over adjacent. The square root of x squared minus 9 over 3 plus ln the absolute value of same. Secant theta is x over 3 plus the tangent theta is same. Opposite over adjacent, the square root of x squared minus 9 over 3 whole plus c, like this. This is like idea. It's good. Just use right triangle for find this answer. So keep going like this. Do we have it? The next thing, you have to simplify. Now you can do that. This is same to 9 over 2. So this is x, the square root of x squared minus 9 over 9 plus ln of same. You can combine x plus the square root of x squared minus 9 over 3 plus c. So this is same to like this. 9 over 2 x times square root of x squared minus 9 over 9 plus, you can change the fraction to difference, the ln, the absolute value of x plus the square root of x squared minus 9 minus ln of absolute value of 3 is just ln over 3. And plus c, the next distribute 9 over 2. The 9 over 2 times x square root of x squared minus 9 over 9 plus 9 over 2 ln absolute value of x plus the square root of x squared minus 9 minus 9 over 2 times ln over 3 plus constant c. But here, what happens? 9 is crossed out. Only x square root of x squared minus 9 over 2 plus, this is absolute value here, the 9 over 2, the ln absolute value of x plus the square root of x squared minus 9. The one more. Negative 9 over 2 ln over 3 is constant. Constant plus constant is also constant. You can write general form of a constant to see. It doesn't matter. So like this. So we have this sense. So like this. Okay. The next problem. 이내건 1 over x squared 9x squared plus 4. So what kind of things do you want to use? So here, we have 9x squared plus 4 form. So we can write the next one. 9x squared plus 4 form. I want to change this one to the 3x squared plus 2 square form. You can compare with u squared plus a squared. Do you remember? What's u? What's u? Which one? Sine function, tangent function, secant function. Yes, we can use tan function. We can use what's u? U equals a times tangent theta. So what's u? U is 3x. So we have use 3x. The 3x equals a equals 2 here. 2 times tangent theta. This is like idea. So we have the 3x equals 2 tan theta. Right? This is the whole idea. So what's that? So we have this one. This is same to divided by 3. So we have like this. 2 tan theta divided by 2. X divided by 3, you can divide by 3, the 2/3 tan theta is right, divided by 3, so like this. The next, find dx. Dx is 2/3 tan theta prime. The 2/3 tan theta prime is secant square. The 2/3 secant square of theta d theta. So we can use 1 plus tangent square equals secant square. We can use this identity. So next, you can change it here. So what's that? This is same to integral 1 over. This x is here 2/3 tan theta. 2/3 tan theta squared. Square root of, what's 3x? 3x is here 2 tan theta. You can plug 2 tan theta. So 2 tan theta square plus the 2 square equals 4 times dx. Dx is here. So we have 2/3 secant square with theta d theta. 2/3 secant square of theta d theta. You can change the like this. So what's that? Here, the like this, and change it. 2/3 tangent theta square is the 4/9 tangent square of theta. The 2 tangent theta square is 4 tangent square of theta. You can change the next. So what is scalar form? What is this one? 4 tan square theta plus 4. So what's that? You see, take out 4 tan square of theta plus 1. What is tangent square of theta plus 1? So what's that? What is tangent square of theta plus 1? Do you know? What is tangent square of theta plus 1? So could you write your answer on the chatting board, please? What is tan square theta plus 1? You're right. Here, secant square of theta. It's good. Thanks. Oh, here we can change it for secant square of theta. The square root is gone. 2 times secant theta. So what's that? You can change this whole thing. This part is same to 2 secant theta. You can change. So we have it. The next is simplify. So take out this one by using reciprocal. 904 times. Take out 2 by using reciprocal 1 over 2. Take out 2/3. So like this. Integral here. Secant theta is crossed out. We have only one secant theta is a numerator. Tangent square of theta is denominator. So like this. Next, cross out common things. Is right. So we have this form. So like this. Next, simplify. 2 is crossed out. 3 is crossed out. The 3 over 4 here. The next 1 over tan square of theta is same to cotangent square of theta. You can change it. So far, not easy to solve this problem. I want to change it to the sine and cosine. Was it like identity of secant theta? What is the identity of secant theta by using sine and cosine? Do you remember? What is secant theta? What is secant theta? What do you think? You're right. 3 over 4 integral 1 over cosine theta. Do you remember what is the identity of cotangent theta? Cotangent theta is, do you know cotangent theta? What is cotangent theta? right? Cosine of sine. Cosine theta over sine theta. Just what? Power 2. So you can power 2 d theta. The next 1 cosine theta is crossed out. We have 3 over 4 equal the cosine theta over sine square root of theta. Sine square root of theta d theta. So we have this result. So like this. So like this. So we are going to here. How can you solve this problem? You have to use U substitution. What is U? What is U? Yes, denominator sine theta is right. Yes, denominator sine theta. Du is sine prime is cosine theta d theta. You can change it. So this is 3 over 4. Equal 1 over the sine theta is here. You plug U square. The cosine theta d theta is du. So like this, change it to the 3 over 4. Equal u to the negative 2 du. So same to 3 over 4. Equal u to the negative 2 is use power 1 over negative 2 plus 1 u to the negative 2 plus 1 plus c. This is same to 3 over 4 times negative 1 times u to the minus 1 plus c. So 3 over 4 times minus 1 is negative 3 over 4 is 1 over u plus c. Right? This is like whole idea. The change back. Was it like u? Negative 3, the 4 times the u is sine theta. This is not a final. So how can you solve this problem? So you have to use previous trig substitution. Here, how can you change back theta to the x variable? To change back here, you can use this one. The 3x equals 2 tangent theta. You have to use this one. 3x equals 2 tangent theta. You can use here. The 3x equals 2 tangent theta. You can divide by 2. So we have 3x over 2 equals tangent theta. You can draw triangle. So what's that? 3x over 2 is opposite over adjacent. You can find hypotenuse y. How can you find? The y square equals 3x square plus 2 square. So this is same to 9x square plus 4. Take a square root. This is same to square root of 9x square plus 4. So we have it. So what's that? Same to negative 3, 4 times sine theta. The sine theta is opposite over hypotenuse. We have the 3x over the square root of 9x square plus 4. So what's that? This is like negative 3 over. This is 4 times 3 is 12x over square root of plus c here. Sorry, this is plus c. The square root of the 9x square plus 4 plus c. You can use reciprocal. The numerator is negative 3 times. The reciprocal of the denominator is the square root of 9x square plus 4 over 12x. The 3 is crossed out, just 4. So final answer is the negative the square root of 9x squared plus 4 over 4x plus c. This is the final answer. This is the whole idea for solving this problem. Like this. All right. So this is like last problem. The last problem is this one here. So let me see. So far, we cannot use the trigonometric substitution because we have negative 2x. We have trouble, is right? So when do you use trigonometric substitution? Exactly a squared minus u squared. The a squared plus u squared. The u squared minus a squared. We have like x term, so we cannot use trigonometric substitution. So how can you use trig substitution for solving this problem? You can change 3 minus 2x minus x squared by using completing the square. So do you remember completing the square? So what's it like completing the square? So we can rearrange the negative 2x, negative x squared, the take on minus 1, so we have it. The next step, you can keep negative, the x squared plus 2x plus 3 is given. You have to add some number, subtract same number. How can you decide these numbers? So I do like this one. You can choose coefficient of x2, the always divide by 2. Next, square this result. Exactly, 1 squared equals 1. So what does it mean? You add 1, subtract 1. This is the idea. We call completing the square. So we call this is what? Completing the square. So like this. This is same to negative. You have to keep whole parentheses. First 3 terms. X squared plus 2x plus 1 is, you can change it to the x plus 1 squared. And negative 1 plus 3. Next, distribute. Minus 1, negative x plus 1 squared. Minus 1 times minus 1 is positive 1 plus 3. This is like a 4. This is a 4. You can interchange 4 minus x plus 1 squared. Right? You can change it like this. So we have it. It's good? This is the idea. So we have here like this. So next, this is same to what? Integral x over the square root of 2 square minus x plus 1 square. So like this. So we have this form. The 2 square minus x plus 1 square, we can compare with a square minus u square form. So what's it like here? So you can use, in this case, u equals a times sine theta. What's it like u? U is x plus 1. X plus 1 equals, so a is 2 sine theta. This is the whole idea. So x plus 1 is 2 sine theta. You can use the trigonometric substitution. This is the idea. 2 sine theta. Just to subtract 1 from both sides. 2 sine theta minus 1. The dx is 2 sine theta minus 1 prime. The sine theta prime is cosine 2 cosine theta d theta. The next, I want to use identity 1 minus sine square theta equals cosine square of theta. The next, so this one is the same to the here, is right? 3 minus 2x minus x squared is completing the square form. The here, so we have it. The next, you plug. The x plus 1 is here, 2 sine theta, you plug. The x is here. The 2 sine theta minus 1. You plug into here. The next one, the dx. The dx is here. So we have 2 cosine theta d theta. You can plug like this. Next, simplify. This inside one is exactly 4 minus 4 sine square root of theta. Factor out for 1 minus sine square root of theta. Just factor out like this. So we have it. Next, you can change this part. The same to what? Square root of 4 times 1 minus sine square is here. Cosine square root of theta. We plug cosine square root of theta. This is 2 times cosine theta. 2 times cosine theta is denominator. So we have it. The next, simplify. So we have integral 2 sine theta minus 1. So what is integral? So what's that? What's integral 2 sine theta minus 1 d theta? So what is the answer? So do you know this one? What is integral sine theta d theta? Do you know? What's integral sine theta d theta? Could you run your answer on chatting board? The negative cosine? Yes, you're right. Exactly, negative cosine theta plus c. So you can keep 2, negative 2 cosine theta. The integral of 1 is just theta. So we have it. Negative 2 cosine theta minus theta plus c. The next, you can change this one to the x variable by using triangle. How can you use? You can use x plus 1 equals 2 sine theta. You can use this one and change it here. X plus 1 equal to 2 sine theta is like divided by 2. So we have x plus 1 over 2 equals sine theta. You can draw triangle. So what's that? This is 2x plus 1. Find y by using Pythagorean theorem. So we have the 2 square plus y square equals x plus 1 square. Subtract 4. 4 is cancelled. Y square equals x plus 1 square minus. Oh, this is like opposite one. Sorry about that. This is made a mistake. Sorry. But not this one. This is not 2. This is not x plus 1. Here, x plus 1 over 2. Sorry. You can use a Pythagorean theorem. The y square plus x plus 1 square equals 2 square. Subtract x plus 1 square from both sides. The y square equals the 4 minus x plus 1 square. So what's that? We are going back to previous one here. This one is exactly same to change back 3 minus 2x minus x squared. So like this. So we have this y is 3 minus 2x minus x squared. Right? So was it like a problem? The weak calculation is negative 2 cosine theta minus theta plus 1. Is right? So here we have this one. You can change it to like this. Is right? So here negative 2. So what's like cosine theta? Cosine theta is adjacent over hypotenuse. The square root of 3 minus 2x minus x squared over 2 minus, how can you find the theta? So you have to use like inverse function. Change back to inverse function. So we have inverse sine of x plus 1 over 2 plus c. You can cross out to the final answer is negative square root of 3 minus 2x minus x squared minus inverse sine of x plus 1 over 2 plus c. This is whole idea for solving this problem, like this. Okay, so this is all for today's lecture. So if you have any question, could you write the question on the chatting board? So if you don't have any question, you can leave the live section. This is all of today's lecture. So you're welcome.